Hi everyone, welcome to today's channel. Today we are going to talk about activation functions in deep learning. The neural network activation functions in general are the most significant component of deep learning. They are fundamentally used for determining the output of deep learning models. In this video, we are going to talk about what is activation function and how activation function works and what are the types of activation function and explaining about nonlinear activation functions. Activation functions are mathematical equations that determine the output of a neural network model, which also have a major effect on the neural network's ability to converge and the convergence speed, or in some cases, activation functions might prevent neural networks from converging in the first place. An activation function is a mathematical function used in artificial neural networks that introduces nonlinearity to the output of a neuron. Each neuron receives input signals, performs a weighted sum of the inputs, and then applies an activation function to the result before passing it on to the next layer of neurons. It must be efficient and it should reduce the computation time because the neural network sometimes trained on millions of data points. The choice of activation function depends on the nature of the problem and the architecture of the neural network. Let's see how activation function actually works in a neural network. From the previous video, you may learn what is neuron and what is neural network. The neuron is basically a weighted average of input. Then this sum is passed through an activation function to get an output. Let's consider the simple neural network model without any hidden layers. The output will be shown as in equation 1, that is y is equal to sigma weights into input plus bias. Here y can be anything for a neuron between range infinity to plus infinity. So we have to bound our output to get the result prediction or generalized results. As it can range from minus infinity to plus infinity, it is necessary to bound the output to get the desired predictions. As you can see in the equation 2, y is equal to activation function of sigma weights into input plus bias. So we pass the neuron to activation function to bound the output value. So the activation function is an important part of an artificial neural network. They decide whether a neuron should be activated or not, and it is a nonlinear transformation that can be done on the input before sending it to the next layer. Next, we'll see what are the different types of activation function we have. Number one is binary step function. This activation function is very basic and it comes to mind every time if we try to bound output. It is basically a threshold-based classifier. In this, we decide some threshold value to decide output that neuron should be activated or deactivated. Which means in this activation function maps any input value to either 0 or 1 based on a threshold. If the input value is less than or equal to the threshold, the output is 0. If the input value is greater than the threshold, then the output will be 1. Basically, this activation function is typically used for binary classification problems, where we have to classify inputs into one of two classes. Next comes the linear activation function. It is also known as a straight line function, where the activation function is proportional to the input, that is the weighted sum from neurons. Here, the output of the function will not be confined between any range. So the next one is nonlinear activation function. Nonlinear activation functions are the most used activation functions, which helps to makes it easy for the model to generalize or adopt with variety of data and to differentiate between the output, which takes the weighted sum of the input and applies a nonlinear transformation to the result, producing a nonlinear output. We will go through in detail about nonlinear transformation. Now we will see what are the different types of nonlinear activation functions are present. The very first one is sigmoid. The sigmoid function is a logistic function and which output is ranging between 0 and 1. The sigmoid activation function translates the input range in minus infinity to plus infinity to the range to 0 and 1. Next comes the tanh. Sigmoid function that will map input values between 0 and 1, but the tanh will map values between minus 1 and plus 1. And the next one is ReLU. The ReLU function returns the input if it is positive and 0 if it is negative. It is computationally efficient and has become one of the most commonly used activation functions in deep learning. Mainly, we use leaky ReLU which is a variant of ReLU. Instead of being 0 when z is less than 0, a leaky ReLU allows a small non-zero constant gradient, which is alpha, which may be any number, which is like normally we use 0.01. Leaky ReLUs attempt to fix the dying rule problem. And the next one is softmax. The softmax function is used in the output layer of a neural network. It produces a probability distribution over the possible classes, with each output value indicating the probability of the input belonging to that particular class. And the last one is exponential linear unit, which may not be, we don't use commonly, but ELU is a function that tends to converge faster and produce more accurate results. ELU is very similar to ReLU except for negative inputs. They are both in identity function for non-negative inputs. That's all for today. Thank you for watching the video.